Related rates. Rate of change, as we know, means derivative. So when they ask you find the derivative, that's fine, the rate of change. So if you pump air in a balloon, so here's in the balloon with a certain radius, so imagine this is a balloon, and you pump air. When you pump air in the balloon, both the volume and the radius of the balloon increase, but their rate of increase is not the same. They're related to each other, but it's not the same. So the radius increase, that's the r dt, and also the volume increases, dv dt. However, it's much easier to measure directly the rate of increase of the volume than the rate of increase of the radius being inside. In related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of the other quantity. So what we're going to be talking about is how these two rates or two derivatives relate to each other. dv dt, the rate of change of the volume, and the r dt, the rate of change of the radius. So in this example, air is being pumped into a spherical balloon. Air is being pumped into a spherical balloon so that its volume increases, at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing? How fast is the radius of the balloon increasing? When the diameter is 50 centimeters. When the diameter is 50. So at any given moment, the rate of change is different. Let's write down what's given. What's given is the rate of increase of the volume. dv dt is 100. If it's increasing, then it's positive. We're going to see later if it's decreasing, then we write that rate is negative. The unknown, or what we have to find, is the rate of increase of the radius, or the r dt. We want to find this when the diameter is 50, which is radius 25 centimeters. So at that particular moment when the radius is 25 centimeters. So what we do, we come up with a formula, or a formula is given to you that relates the two quantities or three quantities. So volume is 4/3 pi r to the third. That's a known formula for volume of a sphere. Now we're going to do implicit differentiation from both sides. Both v, the volume, and r depends on t, not on x, but on t, time. So we're going to take d dt both sides, just like we did before in 2.7. Now keep in mind, pi is a letter, but pi is a constant. So we have on the left side dv dt, that's the rate of change of the volume, which is given. On the right side, we have a constant 4/3, and pi is a constant, so that's not a product rule. It's going to be the power rule for r to the third. R is the other variable, just like y. So we're going to have 3r squared dr dt, because r is a function of t. So now let's look at the question. What we have to find is dr dt. So we need to find this. We need to solve for dr dt. So first, let's see what cancel here. The 3, let's rewrite this nicer. dv dt is equal to 4 pi r squared dr dt. We want to solve for dr dt. So we're going to divide both sides by either divide or multiply by the reciprocal 4 pi r squared. So I'm going to divide by 4 pi r squared, and here divide by 4 pi r squared. So now we can solve for the r dt. It's by itself after this cancel here. And we have 1 over 4 pi r squared dv dt. Keep in mind that dv dt is given. Also, pi is a constant and r is given as well. So now we're ready to substitute. The r dt is what we have to find out at a particular moment when r is 25. So that's 1 over 4 pi, 25 squared, which is 25 times 25, and dv dt was given. That was positive 100. Okay, so what I can do, I can cancel the 4 and one of the 25s with 100, because 4 times 25 is 100. So what's left on the top is just 1, and on the bottom, 25 pi. And we can leave pi as pi and label it. This is going to be centimeters per second. That's the rate of change for the radius. All right, next example. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away, if the bottom of the ladder slides away from the wall, at a rate of 1 foot per second, how fast is the top of the ladder? How fast is the top of the ladder sliding down the wall? When the bottom of the ladder is 6 feet from the wall. When the bottom of the ladder is 6 feet from the wall. So we're going to draw a picture. We have to draw a picture. So here's the wall, here's the ground. Now here's the ladder. The ladder is like this, and it starts sliding down. The length of this ladder is fixed. It's 10 feet. It's not going to change. So let's call the horizontal distance from the bottom of the ladder to the wall here x, and the vertical distance from the top of the ladder to the bottom here y. So the ladder starts sliding away. The bottom of the ladder starts sliding away. So we see this. This, we call it the x dt. That's the rate of change of sliding. And that's given. That is 1 foot per second, right? Now, how fast is the top of the ladder sliding? That's what we want to, how fast is sliding down? That's dy dt. All right, so let's write down what's given. The x dt. That's the rate of change from the bottom of the ladder away. The x dt is 1, so it's increasing, right? So it's positive, and we want to find dy dt. Now, we expect this to be negative because the dy dt is decreasing. The distance from top of the ladder to the bottom is decreasing, so it's going to be negative. And so we want to find this at the particular moment when x is 6 feet. All right, so what equation do we have? It's not given, but we're seeing right triangle here, and we know Pythagorean theorem, so x squared plus y squared is 10 squared. Okay, so let's take d dx both sides, d dt both sides, because we have two variables, x and y, and they both depend on t. So d dt, just like before, d dt both sides. And this is going to be 100. So we're going to treat x and y equally here because both x and y depend on t. So we're going to do the power rule, 2x, and then dx dt, which is like x prime, plus 2y dy dt equals 0. Derivative of a constant is 0. So we want to solve for what? We want to solve for dy dt. That's what we have to find out. So I'm going to keep 2y dy dt on the left side, move the other one to the right, and I can divide by 2 both sides. Let's do that. So we cancel it. And so, oh, I could have divided by 2y. Let's just do that. Let's just divide by 2y both sides. So we have dy dt by itself. So this is gone. The 2's are gone. Dy dt is equal negative xy dx dt. And now we can substitute, evaluate dy dt when x equals 6, that's given. What is y? If x equals 6, so we have this picture again, a right triangle. We have x and y, this is tan, x and y change, tan's always tan the hypotenuse. So we have this Pythagorean theorem. So if x is 6, what is y? We substitute. So we're going to have 6 squared plus y squared equals 100. Y squared, 100 minus 36 is 100 minus 36. Y squared is 64 and y equals 8. So go back here and substitute. Negative 6 over 8. The x dt was given, that was 1, times 1, so negative 4/3. This is the rate of change sliding down, feet per second. So we knew it has to be negative because it's decreasing. The distance, the y distance is decreasing. Okay, a bit easier example here. Each side of a square is increasing at a rate of 6 centimeters per second. Each side of a square is increasing at a rate of 6 centimeters per second. At what rate is the area of the square increasing? When the area of the square is 16 centimeters squared. So we have a square, here it is, and each side is x, and it's increasing. It's like blowing it out. It's growing bigger. And so as x is increasing, the area is increasing also. So the x dt is given. That's the rate of change of increasing of the side of the square. That is 6 centimeters per second. You need to find the a dt when the area is 16. So what formula do we have that relates the area and the side? That's formula for area of a square. It's x squared. So both the area and x depends on the time. As time increases, the area increases and the x increases. So we're going to take d dt both sides, like we've been doing, and both a and x depend on the time. So we're going to have the a dt here equals power rule 2x dx dt. And so this is really easy because it's already solved for the a dt, and all we have to do is substitute. But what is x? Well, if the area is 16, would you agree that x is 4? So now that's 2 times 4. dx dt is given, that is 6. So 8 times 6, 48. Now how do we label the a dt? It's area, so that's centimeters squared per second. And that concludes the video.